I'm giving it, and I'm going to present you a small pet project I developed. You may think after the presentation that the project is garbage. It's fine, it's okay, but maybe some of you think it's useful, so I think it's okay to try. I want to thank Alex to give me the opportunity to talk here. And also I want to thank Shift Spain. I'm working for them, that they allow me to be here presenting this today. So I'm going to present Wimpy. Let's talk about what Wimpy is. Many companies, they have heard about this thing called the cloud, and they want to migrate all the applications from the on-premises servers to the cloud because the cloud promises all these things about the scalability, elasticity, security, all the utilities that you can think of. The problem is that not because you have one server running in Amazon, that doesn't mean that you are cloud native or cloud ready already. You have to do some work. You have to invest time learning these new tools, and you have to invest time doing the tools needed to integrate your platform with these cloud providers. Also, I've seen that in many companies with different teams, or even in different companies, they implement different solutions to solve the same problem. So it's also hard to standardize in a way of deploying your applications to a cloud provider. If a new company today wants to start with Amazon, when you go to Amazon, this is what you get. It's a little bit overwhelming. Like, I don't even know what half of these stuff are. I don't know. So it can be too overwhelming because you don't know where to start, right? So you have time to invest in learning every single piece of software that gets released today. So basically, the idea of Wimpy is a PaaS, a platform as a service that helps you deploy your applications easily to Amazon. The key features or the selling points is that the configuration of how your application is deployed lives in the repository of your application, so everything is together. It's a tool that's easy to run from your CI server, like Jenkins or Travis, GitLab, or whatnot. You can run it even from your own computer if you like. And it's following the immutable infrastructure, so you are not updating your servers, you are replacing the servers in every deploy, so you exercise all the automation in every deploy. And you don't really need to know all the tiny, small detail about Amazon, because it has already same defaults that you can just leave them, and it probably is going to be fine. Wimpy is a tool that is being implemented using Ansible. Ansible is a tool that lets you automate the execution of tasks against some servers. But in this case, we are not going to execute any actions against servers, but we are going to use the Amazon API. And you can use it as Ansible roles that you can install. But if you don't have Ansible or you don't know really how Ansible works, you can use just our Docker container image that you can just run it and it works out of the box. Let's see how to use it. Wimpy is a platform as a service, as we said. We have 3 different roles. Those are the roles that you can find in Wimpy. It's not a tool that you have to use it or nothing. It's composed in 3 different roles that you can choose to use. So I was saying that Wimpy is not an all or nothing kind of tool. You can choose which part of Wimpy you want to use. And it basically has 3 different parts, which correspond to 3 different Ansible roles that you can use. The first one will prepare your Amazon account. The second will help you to build your application as a Docker image, and the third one will deploy the actual application. Later on, we'll see how this works. And the code that lives in your application that configures how the application is going to be deployed is this YAML file. This YAML file is an Ansible playbook that you run. And the important parts are the roles down there, is the parts of Wimpy that you want to execute. In this case, we are executing the 3 parts of Wimpy. And in this part above, we are setting some of the parameters that we want to to tell Wimpy to use. In this case, we are setting the name of the application, the port where our application is listening for HTTP requests, and which hosted song in Amazon is going to use. So after running this playbook, I'll have a new domain called awesomeapplication.armesto.net, which my application will be running in the port 80. To run this playbook, I can use Ansible, but if I don't want to use Ansible, I can use the Docker image. You just have to mount the code of your application, which will contain the YAML file that we just saw, is this one. And then we have some parameters that these parameters will change on every deployment. Your application name is not going to change, it's always the same. Your application port, it keeps the same. But which version we are deploying and against which environment we are deploying are parameters that we may change on every deployment. Those parameters, we pass them on every time we execute the application. In this case, I'm taking the hash in Git for the version of the code that I'm running, and I chose production as environment. So after running this Docker container, my application will be deployed on Amazon. Let's see how these three different parts work together. The first one is the wimpy.environment role, and this role takes care of preparing your account to be ready to accept deployments. Many people create an Amazon account, but they don't know how are the good defaults on the accounts. So when you run this role, you get different environments for your applications. So most likely you will have like a production environment where your application is running for your customers, but you also want a pre-production environment or QA environment, so you can test your application before hitting real users. So Wimpy.environment will create different environments for your application. Each of these environments is running in an isolated VPC. VPC is the Amazon Virtual Private Cloud, which is just a local network. So right from the start, the different environments, they can't connect to each other. They are completely isolated from each other. An application running in production can connect to an application running in QA, for example. So just by running this role, you get all these environments by default. It also configures the CloudTrail in Amazon. CloudTrail is an audit log that keeps track of every change that you make in your Amazon account. So basically, by reading this log, you know who did what and when. Okay, so it's a good practice to have it enabled. You also get an Elastic Container Registry that lets you save all the images for your application. You can also provide your own Docker registry if you want to store your Docker images in another way. But if you don't want to worry about that, this role will create an Elastic Container Registry in Amazon that you can use to store your Docker images. It also will create different security groups for your applications. Those are like the IP tables that will be used in the EC2 instances. And by default, those are the rules that are configured. Basically, the traffic from internet is allowed to the load balancers, and the traffic from the load balancers is allowed to the applications, and from the applications to the database. But by default, any connection from the internet can't connect to the database or to the application directly. It has to go through the load balancer. You can change all of this, but by default, your applications are secure and only accessible by the ELB ports. And lastly, you get the EM roles. EM is the identity access management of Amazon. You can create roles and users with certain policies. And you get all the roles required for your applications to send logs to CloudWatch, for example. So you get all the logs that your application is emitting to standard output, for example. You also get an S3 bucket, so your applications can store images or data or whatever they like. And if your applications have some secrets, like the database username, database password, any credentials your application is using, you also get a KMS key for encryption and decryption of these secrets. When your application is starting, it gets environment variables with the value of the S3 bucket and the KMS key. So your application just knows that some environment variables is going to be passed to them, and it can just use them. So you get everything. These resources every time you execute this role. And those are resources that will be used for all the applications in your account. Next, we have the role that builds and publishes the Docker image for your application. And when I created Wimpy, I decided that Docker was a nice way of packaging applications. It's becoming a standard way of packaging applications. You just write the Docker file, you specify everything you need for your applications to run, and you can create an image that everybody can use to run that application in your computer or in a cloud server or whatever you want. So when you run this role, your application is packaged. We build a Docker image, and we tag that image with the version that you pass as parameter when you executed the deployment. And finally, we publish that Docker image to the registry, which can be a registry that you provided or the registry that Wimpy created in your Amazon account. So now we have already our account ready to get deployments. We have our application image published in our Docker registry. Now we just have to deploy our application. This is the most interesting part, maybe. We deploy the applications using CloudFormations in Amazon. A CloudFormation is just a group of Amazon resources. So you can group together a couple of resources that have a similar life cycle. So you can delete the CloudFormation and all those resources will be gone. And when you create the CloudFormation, all those resources are created together. Basically, we create a CloudFormation for all your application, and we create an auto-scaling group in Amazon, which is just a set of machines that scale together. And all of these machines are running your application using the dumbest orchestration ever, which is every host is running one container. So it's a direct map, one host, one container. No Kubernetes magic here, no Docker Swarm, the dumbest orchestration you can think of. The Docker running with your application inside is being supervised by systemd. So if anything happens, systemd will restart the application. You don't have to worry about that. And the EC2 instances of the autoscaling group are automatically created with the scaling policies. So if the CPU reaches a certain threshold, it will launch new EC2 instances with your application. The same for the memory. And the CloudWatch metrics are already being sent automatically by your application to Amazon. So you don't have to worry about that. You can override the defaults, but if you don't worry, you get the defaults and they are mostly fine. Optionally, that's not required, but most of the times you want to register a new DNS, a new domain, like myapplication.armesto.net, for example. And that DNS will point to a load balancer that will balance the traffic between all your different instances. But you don't have to do that. And when your application is failing, every application has a health check that says if the application is ready to serve traffic or not. If the application is failing, the load balancer will not send traffic to the application, so users won't see the errors. And also, when you deploy, you can choose which strategy of deployment you want to use. Currently, there are two different strategies, which are rolling updates and blue-green deployments. And let's see what that means. When you choose a rolling update, we are using a built-in feature in CloudFormation, which is called rolling update. And basically, you have your group of instances, an auto-scaling group, and they have one of the versions, version 1, which is the gray color, and you start taking one instance down and bringing one instance with the new version. So progressively, you are replacing all the old instances with a new version. If something goes wrong during the deployment, CloudFormation automatically takes care of rolling back to the previous version so you don't lose anything. The another strategy is the blue-green. In this case, you have two different sets of servers, or in this case, you have two different cloud formations, and when you create a new set of resources, and when this new version is ready to take traffic because all the health checks are passing and they are fine, then Wimpy will remove the old cloud formation, leaving only the new version. But this part of removing the old version and keeping only the new one is optional, because Wimpy also supports something like canary releasing. This means that you can select to not remove the old cloud formation with the old version and choose how much traffic you want to send to the new version. So you can have both versions in production running sideways and decide if the new version is getting just the 20% of your traffic because you want to test something. So you can have canary releasing. And this is implemented using the Amazon weighted DNS. So you assign different weights to different DNSs that points to the same domain name. So you can have two domains with the same name, like myapplication.armesto.net, but they are pointing to different load balancers with different weights. So every time you hit that DNS, depending on the weight, you go to one cloud formation or another. So you can test your application with real traffic. Finally, I'm talking about the DNS and load balancing, but sometimes you don't want to do that, because at least in our company, what happened was that we were using already a service discovery solution, which in our case was Eureka. It's a Netflix solution, but you may be using already Consul or etcd or whatnot. So using DNS for service discovery, like I know there is a DNS entry like myapplication.armesto.net that is pointing to this service. That's a way of discovering the instances behind that service, but you may want to use Consul or Eureka. In that case, you don't really need a DNS, because you are going to discover the different applications using your service discovery solution. So you can disable the creation of DNSs and load balancers. In that case, the picture will be a little bit different. This is the picture with a DNS. Like a client wants to send a request to this service, which has 4 different instances. So it goes to a DNS, mathscalability.armesto.net. It resolves to a load balancer IP address, and the load balancer balances traffic between the instances. But if you decide to not use DNS for service discovery, because you're using Consul or Eureka, in that case, the client will ask the service discovery, okay, what are the instances available for this service, for the service called Meetup, for example. So you get the list of instances and you call to whatever instance you want. If you are using a solution like Consul or Eureka, then you don't need to use DNSs and load balancers. But if you want, you can use them. Okay, let's try. Let's see. I don't know how much time I got. Yeah. Okay, so I have here one Spring application. It's an example of the Spring Java framework. It's a pet clinic, which is already running in my Amazon account. The domain is spring-petclinic.armesto.net, and it's running fine. So the sales are going down in my website, and the product owner asked me to do a change. I don't know if you can read this. This is the playbook that we saw in the slide. It's the same YAML file. We just use the 3 roles of Wimpy, and we pass the needed configuration. There is one configuration here, one new configuration, which is which path is going to use Wimpy for the health checks. And this Spring application is exposing an endpoint called /manage/health to say if the application is running fine or not. So I tell Wimpy to use that specific endpoint. By default is /health, but if you have another one, you can just override it. Also, I'm including here some parameters, but those parameters are going to be environment depending. So if I'm deploying against production, this will load in memory the production.yaml file. If I am deploying to staging, for example, this will load the staging.yaml file. And those files, I also have them in the repository. Here, I have my deploy YAML, which is this file. I have a production YAML and a staging YAML with the specific configurations for every environment. For example, in the staging environment, you want a different domain name, like petclinic.staging.armesto.net, for example. I also have a script which is using the Docker image that we saw in the presentation, also passing the commit, the Git commit that we are just merging. And this is going to be executed on Travis. That way, every time I make a change, I get my application deployed on Amazon. So my product owner asked me to make a change because the sales are going down. My welcome page is showing this cat and this kitten, but I have a better kitten to use. So let's use this kitten. I think I can increase the sales by 20% by using this kitten. So let's use that kitten. And let's see. I have the change already. This is my change, right? My kitten.
Kitten JPG.
Really?
Yes.
Okay, the QA is working. Thank you. Okay, now it looks fine. Yeah? Okay, the QA has approved a change. Now I can just add the file and commit the change, right? And let's push this. You didn't see the force. Okay, let's push the change to GitHub. This will save the code to my GitHub repository, and I have Travis connected to the repository, so Travis will be executed. We can see that here. So my last commit, which was kitten for the wing, is here, is being executed now, right? It's going to take a little bit. Let's see here. This is my Amazon account. Let's see, let's increase the font a little bit. This is my CloudFormation section. So I told you before that Wimpy was creating a lot of resources, right? But it's not like we create one CloudFormation for everything. We create different CloudFormations. So we have a base CloudFormation. This is a CloudFormation that takes care of the S3 bucket that will be used for all the applications. It takes care of the KMS key for encrypting and decrypting that will be used for all the applications. Stuff like that. Stuff that is going to be used for all the applications. Then it creates different environments, right? By default, it creates two different environments, production and staging. But you can choose to create more environments if you like. As we mentioned before, those environments are completely isolated and they are created using VPCs, like local networks. Then I have two different applications right now. I have the Spring example application, which is this pet clinic, and a Symfony example application. Each of those has they have some resources. These resources include the security groups needed to allow traffic to, from the internet to the application port and the load balancer. It includes the repository to save the Docker images for that application and application-related stuff, right? So we have one CloudFormation for each application. And then we have one final CloudFormation for the deploy itself. If we are using the rolling update strategy, we have just one CloudFormation that is going to be updated every time. But if we would have chosen the blueprint deployment, then we will have different CloudFormations for each new release. And the name of the release will contain the Git hash commit. So you can see, you could see here all the different releases of your application, right? In this case, we have chosen the rolling update for a Spring Pet Clinic. So now, in a couple of minutes, we'll see how this is getting updated. Let's check on Travis to see what's going on. Okay, Here is the build, and the build is being executed. It's a Java application. It's using Maven, so now it's creating the build, right? And also, I have my Docker file that Wimpy will use to create my container, and this is the Docker file I'm using. Ignore, yeah. And I'm also using the new Docker feature of multi-stage. So if you can see here, I have two different from statements. In the first one, I'm using Maven to create the jar of my application. And when that is done, I'm using a minimal Java image to copy the jar from the first image and copying into this minimal image. Finally, I just execute my application like any Java application. So let's see how this is doing. More, okay. Here, the build just ended, right? Build success. And now, my script, the deploy sh, has been triggered, and now Wimpy is being executed, executing all the different steps. Since I'm executing all the different roles, Wimpy is making sure that my base clause formation is still up to date. So if somebody has came here and changed some of the resources by hand using the Amazon user interface, those changes will be lost like tears in the rain, because Wimpy will update again on the next deployment, right? Some people may think that that's bad, but I think that actually that's good, because if you want something to change, you have to do that by code, not by hand. And also, we'll check if all the environments are up to date, and so on, and so forth. So here is checking everything, and now is building my Docker image and pushing the image to my Docker registry. I told you before that the Docker registry, since I have not passed a different registry as parameter, Amazon has a service for this, which is EC2 container service. And apart from ECS, that is a tool to execute containers like Kubernetes, it also has a Docker registry. Here you can see my two different applications. I have two different repositories. Every repository contains the images for my application. If I enter here, I have all the different releases that I've made for this very application. So the images are being tagged. This is the tag for every release, and this is the Git commit. So you know exactly what version of your application is inside that container, that image, sorry. Here I'm using the Git hash, but you can actually use any tag that you like. If you want to tag your versions like v1.0, that's fine. It's just a tag. But I like to use the Git hash because I know exactly what's inside that image. Okay, so it's publishing my application here. It's already finished, and now it says creating CloudFormation for deploying the application. If I go to the CloudFormation part, here, it's being updated. Let's test something. This is making a request every second to the application and taking the small hash of my version, of my current version. And let's see what happens when Wimpy kicks in. Because I'm saying that we have 0 downtime deployments. So let's see if I put my money where my mouth is. And let me check this 1 second. Okay. Let's minimize this. Okay, the CloudFormation is being updated. I have my old version yet. This is working. Okay, no, I'm not cheating here. And let's see if the demo gods are with me tonight. Are you nervous? Because I am. Actually, what will happen is that when the new version kicks in, I will get, for just a little bit, I will get the two different versions at the same time, right? It takes a while to deregister the old version. So you have to make all your versions compatible with each other, at least with one version before.
What strategy are you using right now?
Right now is the rolling update. See, I have my version here. I have my version here. Now this is being switched. Wait. You have to save your upload for this. I got the old version now. Oh. Okay, I messed up, but you can see the change, right? Okay, so now we have the two different versions running at the same time, and after a couple of minutes, we will see only the new version being deployed. So basically, to sum up, Wimpy is a tool that you can use to automate all your deployments to Amazon. You don't need to learn all the resources of Amazon before starting to use this. See, now we have only the new version. And all the defaults that are being used are like good defaults, and you can override everything you like. And it also has support for canary releasing, for different weights and different deployment strategies. So basically, Wimpy is what it is. It's open source. Everybody can contribute, and I'll be happy if you contribute. And thank you very much.
As far as I can tell, the Wimpy environment role doesn't actually deal with persistent data stores like databases and key value
It's only
stores.
taking care of the stateless applications.
So how do you plug in your database and your key value store into a VPC that you're creating by the looks of it from scratch?
When you create the different environments, you have the different VPCs and apart from the VPCs, I have different security groups for the answer application and also databases. So, for example, if you create a new RDS in Amazon, you can choose to assign the database security group to the RDS, and you can choose to use the VPC that you have created.
Okay, so you have to do it after the fact, after the first deploy.
Yes,
Okay.
yes. The good thing is that everything created here in the transformation, for example, the staging environment, is exposing everything as outputs. So you can consume those outputs from, for example, another Ansible role that creates your data.
Cool.